And this is the syllabus: general theory of transmission lines, central solutions, characteristic impedance, propagation constant, attenuation and phase constant, open and short circuit lines, the telephone cable, a reflection of a line or time ranges or not, reflection coefficient, distortion in transmission lines, and distortion less lines. And if we are going to try consider about the transmission lines, the transmission of energy from one point to another point takes place through either wavegates or transmission lines. The transmission lines always consisting of at least two separate conductors between which a voltage can exist. Wavegates are involves one conductor, and there are two types of common used transmission lines are parallel wire or balanced, and another one is coaxial line which is unbalanced. And this is the diagram which represents our parallel wire line and a coaxial line. Parallel wire is nothing but a balanced line, and coaxial line is an unbalanced line. Parallel line is nothing but we have only two conductors, only outer conductor casting and another one is conductors. And coaxial cable we have outer conductor also inner conductor. In between you have outer conductor inner conductor, we have dielectric material. And this is the topic we are going to say about the transmission line circuits considered as a cascade T sections. And one T section is round is one transmission line, and this is the purpose. We are going to connect all the T sections are in a series form to make the transmission and line. So this is the analysis, and this is the general diagram of our transmission line, which consisting of resistance, capacitance, inductance, and also conductance. And from this diagram we can analyze that primary constants, secondary constants, the four line parameters are resistance, inductance, capacitance, and conductance considered as the primary constants, whereas characteristic impedance and propagation constants are considered as the secondary constant. And this is the diagram shows our one portion of our T section, transmission line T section, transmission line equation. We have a general solution for this, and the purpose of general solution is nothing but we can able to find out the voltage and current at any point on the transmission line. At any distance we can able to measure the voltage and current of a transmission line. This is the main use of our general solution. So after solving these equations we can able to find out the solution. Directly we will go for the solution, and V is equal to VR cos sketch root of Z is x plus IR Z naught sin h root of Z by x, and I is equal to IR cos sketch root of Z by x, and VR by Z naught sin h root of Z by x, root of Z by x Z will be replaced by gamma. This is the solution. Vs and Is. Vs represents our sending end voltage, Is represents the sending end current. Thank you.